A client wants to demolish his existing single-story bungalow located in Petaling Jaya and build a semi-detached house with double stories within a total built-up area of 4,210 square feet, and the estimated cost is 1.09 million based on the location and the area of the land. He is open for any architectural style but prefers to have a curtain wall facade for the double volume living space with watertight design. The house also needs to achieve gold rating in Green Building Index. The owner wants to subdivide the land for 2 new owners. So, what is the function of the building? The semi is for residential purposes and it must have an eco-friendly concept by accumulating 76 to 85 points to achieve the gold rating. They fall under the criteria of having high energy efficiency, high indoor environmental quality, sustainable site planning and management, using good and suitable material and resources, high water efficiency, and innovative. This project involves 5 phases in the construction process. Number 1, the schematic design phase. Number 2, the design development phase. Number 3, contract documentation phase. Number 4, contract implementation and management phase. And number 5, the final completion phase. It begins now. In the schematic design phase, the architect will first take the client's instructions and analyze the project brief. He will then set up the project team. However, in this scenario, a town planner and a facade specialist is not needed as it is only required in large projects.
The land surveyor will conduct a demarcation, detailing, and spot leveling survey such as measuring distances and angles on the property, and perform mathematical calculation which serves as the basic information for the architect and other consultants to develop sketch proposals.
Then the landscape architect will undertake site inventory and analysis using the survey plan provided.
Prior to the development of all the sketch proposals, the GBI facilitator will advise the architect on the building orientation to increase the energy efficiency of the building.
Next, on behalf of the client, the CNS engineer will appoint soil specialists to conduct soil investigation on the site. He will then analyze the site conditions, infrastructure, drainage, traffic considerations, and all environmental conditions related to achieving a cost-effective design solution. He will then proceed by producing a concept design report, which includes all required drawings, key details, and a design commentary on materials and finishes.
Moreover, the M&E engineers will provide preliminary information to enable the architect to sketch plans which includes preliminary equipment list, electrical power estimation, and water consumption estimation. He will then prepare a design intent document to enable the client to consider the consulting engineer's proposals, including the alternative proposals for the installation of the works, whilst keeping in mind of the possible constraints in the form of budget and space. After that, the architect will develop the preliminary conceptual sketch proposals into sketch designs.
While the landscape architect develops preliminary landscaping conceptual sketch drawing.
The architect applies for planning approval with sketch designs from all consultants, prepares and submits the layout plan and other documents such as land title and latest land search based on the checklist issued by MBPJ to Jabatan Perancangan Pembangunan MBPJ via online one-stop center.
The land surveyor applies for electricity, water, and a permit to work on the land, hands in Borambi, and subdivides the land in collaboration with the architect.
The interior designer identifies the client's needs and objectives based on functionality and relationality and also budget. She then discusses questions regarding the space with the client. Moving on, she proceeds to take measurements and photographs, develop space planning and floor plan through rough sketches and develop preliminary furniture and finish ideas. After checking with the architect to ensure coherence with his design, it is presented to the client for review and revision. The cost estimate is then submitted to the QS to keep track of the budget.
Finally, the quantity surveyor will prepare estimates of the probable construction cost based on the current area, volume, or other unit costs. Concurrently, regular meetings are conducted between the client and all consultants to refine and complete the stage. Next, upon obtaining town planning approval from MBPJ, the architect and the landscape architect will develop schematic design drawings to enable other consultants to begin their detailed design work. The drawings should comply with UBBL. The architect will submit building plan and temporary building plan to Jabatan Kawalan Pembangunan MBPJ through OSC to obtain approval. He will then apply for waste container from Jabatan Pengurusan Sisa Pepejal.
The CNS engineer will prepare dilapidation report and method statement of demolition work to be submitted to Jabatan Kawalan Bangunan. The structure plan is submitted to Jabatan Kawalan Bangunan, while earthwork, road and drainage plans are submitted to Jabatan Kejuruteraan, or to MBPJ through OSC. The CNS engineers will also submit water reticulation plan to Shabas, and sewerage reticulation plan to Indah Water Consortium.
The interior designer works with the M&E for the provision of electrical fittings such as socket and lighting points.
Then, the M&E engineers will submit electrical plan to Tenaga Nasional Berhad and the telecommunication plan to Suruhanjaya Komunikasi dan Multimedia Malaysia.
At the same time, GBI facilitator completes and submits the application and registration form to GSB with supporting documents. Then she will conduct meetings with other consultants to set individual tasks according to project brief, costs, and critical issues that may impact the GBI score. After that, she starts preparing the design development process evaluation report. It is then submitted for GBI design assessment.
Next, the interior designer does the interior design based on the base plan and client's requirements and other items in greater detail after getting the final approval for the schematic design. She will then refine colors and finishes, select furnitures, fabrics, and equipment, and prepare cost estimates to be presented to the client for review, revision, and approval.
The landscape architect determines major issues such as topography, drainage, budget, access, and services, and start to develop detailed drawing based on client needs.
The quantity surveyor will update the preliminary estimates of construction costs based on the consultant's works. Lastly, the architect will prepare project planning and implementation schedule to ensure that the project can be completed on time. Architecture meetings are conducted between the client and all consultants until the client approves the design works and estimates of the construction costs. Upon client's approval of the updated preliminary estimates of construction costs, project planning, and implementation schedule, the consultants will prepare and finalize detailed drawings with adequate information to enable bill of quantities to be prepared by the QS.
The interior designer documents specific details of the work to be completed such as millwork specification, finish selections, and fixture location and selection.
The contractor receives and reviews bid documents, requests for quotation, and compiles a comprehensive list comprising the total scope of work including labor, materials, and equipment. He then conducts a site inspection and submits the proposal with specification, proposed subcontractor, tender price, and schedules.
In the meantime, the QS advises on procurement, tendering, and contractual procedures and arrangement. In collaboration with other consultants, the QS leads to prepare tender documents for all work packages except for M&E engineers and interior designers, while the contractor undertakes the pre-qualification set by consultants. The architect and the QS also reviews all tender documents.
The GBI facilitator also reviews all tender documents to ensure that everything is suitable to achieve the project brief requirements as well as the GBI target score.
The architect invites tenders for the main building works while the M&E engineers pre-qualify, shortlist bidders and evaluate bids and proposals from tenderers on behalf of the client.
The interior designer pre-qualify, shortlist bidders, evaluate, and obtain bids, and then issue purchase orders on behalf of the client for the interior works.
The contractors will submit tender documents to tender committee by the tender closing date.
The consultants of the respective work packages arrange with the client to fix a date for tender opening, and they conduct tender interviews with the contractors respectively.
A revised version of tender documents will be submitted by the contractors after tender interviews.
Following that, the consultants will evaluate the tenders and submit a report and recommendation to the client for their respective work packages. The architect will award the contract to the lowest and most responsible bidder, also known as the contractor. Then he prepares the building contract documents in collaboration with other consultants for a signature between the client and the successful contractor. Concurrently, architect chair meetings are conducted between the client and all consultants regularly to refine and complete the stage. In the following stage, the architect notifies on the commencement of work by submitting Borang B to Jabatan Kawalan Bangunan MBPJ through OSC. He then hands over the site possession to the main contractor, while the M&E engineers examine the contractor's proposals and make sure that the quality and health, safety and environmental aspect is complied.
The main contractor submits contractor all-risk, workman's compensation insurance policy, and a detailed work program, management and site organization chart to our architect prior to the commencement of work.
Then the architect examines all the items mentioned earlier to ensure that the works can be reasonably done within the contract period.
The contractor will develop a safety and health manual to safeguard the health and safety of the public and employees.
The landscape architect manages full site supervision including the approval of construction, payment as well as variations under the client request.
The CNS engineers ensure that the contractor's requirements with respect to documentation flow and on-site activities are satisfied under the architect's supervision.
Next, the contractor conducts a pre-construction site meeting with all key subcontractors, employees and material suppliers.
The CNS engineers review contractor submissions, including workshop details, temporary works documentation, and use the best endeavors to ensure that the safety, quality, and intent of the design are fully complied. He assists the contractor with variation price requests, recommends alternative materials, and provides any documentation required due to material non-availability.
On the other hand, the GBI facilitator meets with the contractor to establish GBI requirements in line with the project brief and GBI target score.
The contractor prepares manpower and construction machineries on site, erects temporary building for construction and commences the works on site.
While the CNS engineers ensure that the inspection start-up and commissioning procedures provided by the contractors comply with the project brief. Then he coordinates and checks operating and maintenance manuals prepared by the architect and checks compliance with the architect.
The architect, M&E and CNS engineers visit the site to make sure that the works are executed according to the contract document and with good engineering practices.
At the same time, the contractor coordinates, supervises and inspects all works in progress for strict adherence with all the requirements of the approved plans, building codes, ordinances and standards.
The architect updates the client on estimates of the cost and duration of the site staff's employment, whilst issuing instructions to the contractor as required under the terms and conditions of the building contract to enable the contractor to proceed with the works. He inspects the works at periodic intervals so as to ensure that the works are being executed accordingly in order to issue a certificate of practical completion.
And the interior designer must be on site during installation to ensure that items are received in good condition, installed correctly, and documents have been abided.
The contractor also conducts periodical coordination meetings with the subcontractors and suppliers. The GBI facilitator ensures that all the prerequisite GBI documentation are obtained from the contractor to submit for accreditation.
Finally, the M&E engineers approve the contractor's performance tests, commissioning procedures, installation methodology, and inspect the works regularly until completion. Architect chair meetings are conducted between clients, consultants, main contractors, and subcontractors regularly. In the final completion phase, the architect leads other consultants to arrange inspections from the relevant authorities to obtain clearances to facilitate the preparation of Borang G1 to G21 to support issuance of Certificate of Completion and Compliance. The forms are submitted to MBPJ and LAM, while a copy of it will be kept by each the client and the architect. The architect will issue a certificate of completion and compliance for the building after being satisfied that the building is fit and safe for occupancy.
The GBI facilitator does commissioning, monitoring, and fine-tuning to test building performance. She later submits to GSB for completion and verification assessment upon completion of the project. The building is awarded Gold rating depending on the score achieved.
All equipment tests shall be thoroughly documented and copied by the contractor to architect and the client.
The CNS engineers arrange for the provision of all as-built civil and structural engineering documents.
The M&E engineers deliver to the client copies of as-built drawings, contractors' operating instructions, manufacturers' manuals, certificate of work tests, certificate of supervision and completion, and arranges for the delivery of spare tools to the client upon completion of the works. The architect then certifies as-built drawings and submits maintenance manuals together with all warranties to the client.
All required inspections and reports of all testing results shall be completed by a contractor and signed off by all parties. This is followed by hauling away all debris from the site. Then the contractor turns over all keys, warranties, and maintenance manuals to the client.
The landscape architect is required to attend and submit reports during or at the end of the maintenance period to ensure that project is being properly maintained.
Finally, the architect collaborates with the QS to prepare statement of final accounts for the contract and issues the final certificate of payment to the contractor at the end of the defects liability period, provided that all patent defects have been rectified.
This is a client. What actually makes up a good client? A good client should possess these 4 qualities, which are cooperation, patience and trust, realistic, and punctuality. The client should be cooperative by having clear goals and picture and should be responsive. Clients should not doubt and allow the consultants to do their best as possible as they can. Clients should set realistic expectations and make a reasonable request aligned to the set budget and conditions. Lastly, the client should pay on time in order to pay for material and labor-wise.
This is an architect. So what do good architects possess? A good architect should possess skills in leadership, drawing and sketching, and problem solving. Leadership skills are required when leading a professional team consisting of consultants and builders. An architect must have a lot of drawing and sketching skills, either via computer programs or by hand. Problem solving skills are also essential for an architect in order to identify problems and develop rapid solutions to address them. This is the quantity surveyor. So, what makes a good quantity surveyor? A good QS should have the ability to stay composed because it allows them to tackle their work in prime condition to ensure that the tasks are completed without compromising company standards. Secondly, being meticulous. Being extremely attentive to the drawing's details enhances accuracy of the cost estimation. Lastly, they need to be organized. Quantity surveyors should keep with all figures, data, and paperwork if they are to give timely recommendations to the client so that productivity is maximized.
This is the land surveyor. And what makes a good land surveyor? This. A good land surveyor should be able to do complex measurement related to elevation, angles, and distance. They also require to be skilled with mathematical calculation like geometry and trigonometry. Research and data gathering skills are important as they will consult historical and legal records. They need to pay attention to details as the accuracy of a land surveyor measurements is important in construction projects.
This is a CNS engineer. So, what makes a good CNS engineer? A good CNS engineer should possess skills in visualization, technical, and project management. Visualization skills are crucial to identify and resolve issues before they can become problems. Next, skills in mathematics and physics are required to apply the appropriate principles in his design works. He also needs skills in design techniques as well as computer programs. Lastly, he should be able to manage the project by evaluating the work of the artist.
This is an M&E engineer, so what skill does a good engineer have? Well, these are the three main skills. They are experts in mathematics, physics, and chemistry as they need to apply complex theories based on their knowledge on them. They are critical thinkers because they use reasoning to identify the strengths and weaknesses of alternative solutions, for instance in Phase 1. Lastly, they have advanced technological literacy by mastering the machine's testing, reading, construction, and design aspects.
This is the GBI facilitator. So what makes a good GBI facilitator? A good GBI facilitator should be proactive in promoting green building technologies and get the building team to agree on the highest possible certification level. Next, communication skills is important to communicate effectively with the other consultants and also the client to understand their goals and vision for the building. Lastly, creative problem-solving skills is important to deliver innovative solutions when facing issues.
This is the interior designer. So, what makes a good interior designer? A good interior designer requires skills in communication, creativity, and problem solving. Excellent communication skills ensure work being performed is precisely what the client wants. Next, an ID must have a strong sense of creativity to easily generate new ideas for design. Lastly, an ID needs a good problem solving skill to quickly develop a solution when a problem arises. These are some of the basic knowledge an interior designer should have.
This is the landscape architect. So, what makes a good landscape architect? Landscape architects should have multidisciplinary thinking skills to be able to synthesize information based on client needs. They also need to master computer software to produce better computer-aided design. It is important for landscape architects to be persistent as they will be working long hours for their projects.
This is the contractor. So what makes a good contractor? These are the qualities of the contractor. First, the contractor must communicate effectively during the estimate and bidding process in order to be awarded as a main contractor. Next, integrity. Contractor must be able to rectify the problems and keep the work site organized. Lastly, flexibility. The contractor must take on every aspect of a construction project within the time frame.
To conclude, without the client, team players, and local authorities, the construction process would be incomplete as they each play an equally significant role. Laws such as the UBBL and the National Land Code governs and regulates the whole process to ensure that the project conforms to a certain set of standards. Needless to say, construction processes was what shaped the past into the world that you and I both live in today. Therefore, it is important to note that it is not only the beauty of a building that we should appreciate, but also the laborious process that made it possible.